Hi everyone. My name is Boyan, and I'm from StorPool. I'm here to talk to you about this stuff, measuring and tuning VM performance. It's a, in my mind at least, in our mind, it's a very misunderstood subject, performance. So we try to, tell people about it and how to do stuff. This is kind of the abstract. So I'm going to talk about measuring performance and also about best current practices. Why do we need to do this stuff? Mostly because your users care, right? So your users care how fast their page opens, how quickly their Windows VM boots, how fast they can log in, etc. Right? So there are two directions you can think of in this. One is your users are happier. The other is through performance, through density, you can get a better cost of infrastructure, right? So cram more VMs into a host, you get a lower cost per VM, right? And I have this mandatory inspirational quote, which every presentation should have. Well, this is from Zen and the Art of Motorcycle Maintenance. And I think about half of the audience are from like scientific and academia circles. For the other half, we think it's very important to apply the scientific method when working with this stuff. So quite often I see people are basically scared of measuring stuff because the outcome may be bad, right? So it's probably okay, and I don't want to measure it because, well, it's okay. I don't want to measure it and create trouble for myself, right? And our view is you need to do quite the opposite, right? So not only stuff that you doubt about, stuff that you are confident in, you should measure, right? What to measure? What your users care about is application performance, so how fast their page opens. This is very application specific and in some cases hard to measure. So then you have to settle for the second best thing, which is proxies for application performance. And then the most common way this stuff is measured with synthetic workloads, which are very far from what real applications look like. And an important part to understand at this stage is the difference between throughput and latency. So throughput is 2,000 kilos of apples per day, which is, you can think of it, you are a market and you order apples and they arrive and you sell 2,000 kilos of them every day. Latency is usually what users care about. It's, how fast can I get the first apple and eat, right? Or load the page or whatever. Most published benchmarks of lots of systems out there focus on throughput, not on latency, which is stupid. So how does an example for application performance? This is a kind of it's from an embedded tool in web browsers. You can see how fast each part of a web page loads. And what your users care about is really this number down there. So how long does it take for them to see the web page? This is an example for latency. An example for throughput is how many visitors can your system sustain without going over a certain threshold of latency, right? And again, this is very application specific, so every application would have its own important metrics, right, for latency. Proxies for latency, proxies for application performance. One thing you can do is, for latency, you can take the whole time it takes to perform this operation important for the user, break that down into parts, see how long each part takes, and focus on the parts that are longest, right? So focus on the critical path, focus on reducing the time it takes for the longest parts. On throughput, it's a different ballgame. When you are optimizing for throughput, you need to find the bottlenecks, find the part of the system that's running at 100% and is constraining throughput. What does that mean? Means when you open up that bottleneck, performance will increase, throughput will increase. If you open up any other part of the system, if you increase the performance in any other part of the system, performance would usually not increase, right? An example for this is find the largest contributors, say a database insert could be an example for this. Then you have synthetic workloads. So for the stuff that we do, the most common ones, which is storage, the most common ones are these for throughput, which is like random and sequential workloads of various kinds. And real workloads don't look like this at all. Like they have nothing to do with this. Not at all. And then for latency, these are the most common ones people use. And then there is also latency under load. So you have a workload, and then separately from that, you measure latency. Examples of, again, in storage, how this is a throughput test. You can tell by the high I/O depth. In this particular system, there's 100,000 or so IOPS at the latency of about 3 milliseconds each. Most of this latency is queuing latency, meaning because there are 256 operations in parallel, they complete at a certain rate. It just takes time for the operation to go through the queue. Also, just this number, 100,000 IOPS, doesn't mean much unless you know what the system underneath is. And there is a kind of a short description of what that system is. And this is an example for a latency test. So this is random write 4 kilobyte block size I/O depth 1. The number that you care about is this one here, which is 150 microseconds average latency. Same system underneath, right? Yeah. Second part, best practices. So you have 3 parts in this, which is the compute platform, which consists of hardware, some settings for that hardware, some settings for the operating system. You have a network and a storage system. Typical hardware our customers use looks like something like this. So lots of cores, fairly high frequency, lots of RAM, like 512 gigabytes of RAM, and say 4 times 10 gig is typical network. Firmware versions of BIOS, power management for the CPUs and the rest of the system. And in most cases, when we work with our customers, they're looking for kind of lowest cost per delivered resource. So they don't necessarily optimize for the lowest possible latency ever, which is going to be a lot more expensive than per VM than this system. So this is kind of a optimized for density as well as performance, right? A good reference for the next step, which is operating system and virtualization optimization, is this thing, which is Red Hat's virtualization tuning and optimization guide, and I've also included some other references in the slides. And another note here, please don't do this blindly. I see so many people go on Stack Overflow and they find some advice of how to do stuff, and they implement it blindly, and they think it works, right? You need to perform your own benchmarks on your own system, right? Because there are subtle differences between systems, and it's not so simple. Advice doesn't apply to all systems out there. It's different in everyone. Host operating system, guest operating system. Most of your hardware tuning or operating system tuning is handled by these guys. Tune the Atom virtual host and virtual guest. If you are inclined to, you can go and look at exactly what these profiles do, which is settings for the CPU, settings for some ccTL parameters, settings for network queues, etc. And then the other part is use a good version of QEMU and KVM. In our experience, QEMU KVM EV from Red Hat Enterprise Virtualization has been quite good for us. They are kind of newer and more bleeding edge versions of QEMU, but use at your own risk, basically. They're not so widely used, so widely tested. In networking, use the VirtualNet driver, nothing else. And there is also, this is a situation where you have the choice between functionality and higher performance. So if you go with SRIOV, pass through the network interface card directly to the VM, you lose functionality because you can't do anything special with the packets of the virtual machine in the host. And there is a trade-off here. Most people go with VirtualNet, and that's good enough for them. For block I/O, these are the settings you need. I'm not going to go too deep in them. It's just use this as a reference, right? For memory, there is another trade-off here between, on the top side there, memory efficiency, so like reducing the amount of memory VMs use, and on the bottom side, performance. So KSM is incompatible basically with huge pages because of the way it works. Memory dedupe needs 4K pages. If you use huge pages, it doesn't work. So most customers go for the bottom type of things, most of our users. CPU is heavily oversubscribed because of this, efficiency gains, basically, and because most VMs are idling, but it's very use case dependent. There's CPU pinning, hyperthreading, NUMA awareness, and all that. For networks, nothing special really. So these are just regular 10 gigi or faster switches. And you only need VLANs, jumbo frames, and nothing special there. For storage, our part, there's lots of snake oil out there. So you would see storage vendors especially advertise performance numbers on hardware configurations that are not at all like what you would use in production. Synthetic tests with huge I/O depth. So real applications are actually issue very few operations in parallel. So you can think of, say, I/O depth 4 being representative, not I/O depth 2000, like things we see out there. And testing without real hardware underneath. So they would put, say, a RAM disk behind stuff. Keep in mind, most published benchmarks on storage systems are synthetic workloads which don't represent the real world. My example on that is, we recently had a customer who, based on a synthetic test, thought our system wouldn't perform faster than a RAID 10, and with the real workload, it does. Right? So the real workload, so our system is better suited for the real workload than for the synthetic test, which is rare, but there are occasions like this one when it happens. And as a conclusion, I think performance matters for your users. Understand that and work to improve it, and work with partners like us who understand this and can help you with it. And that's my slides. Well, thank you.